Hi there, let's talk today about how to get SRT up and running on Ubuntu. I have here a clean virtual machine with Ubuntu 20.4 that's fresh installed with minimal features, and I will try to get SRT up and running here. So first of all, SRT is an open source protocol you can find on my GitHub. I will go to GitHub and search for SRT. Of course, if you know the location, you can go straight to it, but it's located in hivision/SRT. And here is the repository we have here. So there is a README file which describes SRT in a bit, gives some introduction, but if you want to get yourself familiar with the protocol, you can check out the quick introduction on this channel, or read RFCs and go to Cookbook, for example. We will also go here after some time. But anyway, here I will not focus on SRT. We'll go straight to try to build it and use it. First of all, let's try to just take SRT and build it. You can see the section with requirements in the README. Of course, I need a compiler, C++ compiler, C++03, which is very flexible to most of the systems you would use there. CMake 2812, OpenSSL library. It's an optional library, so you can build without OpenSSL, but in this case you will not have encryption. It may be a quicker start for you, so you don't need to install everything, especially on some other platforms, but we will go ahead and build with OpenSSL to secure our payloads with encryption. We have Ubuntu, so let's go to build to Linux. There is some introduction here. So instructions for Ubuntu 14. You would first need to update your apt-get and upgrades. I will skip this because I have the latest Ubuntu and it's okay. First of all, let's go with this tools. So we need to install TCL SH. It's not something we will definitely need, but might be useful for some scripts. Package config is mainly to find external packages like OpenSSL. CMake is a tool to generate make files, which will then be used to build SRT. libSSL is the library which will provide encryption. Build Essentials has all the essential build tools like compilers and so on. So let's go on and open my terminal. I will create a folder called projects just to work there. Let's go to projects and first of all, let's install the tools we need right here. Okay, it will take some time. Okay, now it's installed and ready to be used. So first of all, we still don't have SRT in our disk. So let's go ahead and clone the repository. So to clone the repository, there is this code button, and I will use HTTPS. It's just a simpler. So if you don't know where to go, just use HTTPS and copy this link to the repository. But eventually the link is formed similar to the location of the repository. So you can just take this one and add git here and you will get it. Anyway, let's go with git clone. So git clone, git clone and SRT. Then you can specify the folder you would like to use. By default, it will be SRT, so the same as the name of the repository, but you can specify something. So let's specify SRT version 143, for example, or 144. Let's use the latest one so far. Okay, so git command not found. Okay, we need to install git, so it's not a build essentials. apt-get install git. Yes. and trying the same command. Okay, now it's working, cloning the sources, and we can see that we have this folder srt version 144, so we can go inside srt version 144, and we have the sources here, same as we have in this GitHub. But what we've cloned is the master branch. So to check out the latest release, so currently is the latest release is 143, but there is also release candidate 1 and 0 and so on. So to check out specific version, if you need it, you can just be inside the folder. Well, it's the basics of Git, but anyway, git checkout and the branch name. So for example, let's check out version 144 RC1, for example. Okay, and now we have this branch checkout. So it's fix Solaris build, the latest commit. Yes, I'll use git log to check the commits. And if you go here, we see that it's exactly the commits for this tag. Okay, now let's proceed working with this version. What do we do next? Let's follow the instructions for Ubuntu. This one we done. This one is to configure. So it's easiest way. We've installed the shell script and we can run configure straight away, and will be a bit easier. But if you want a bit more hands-on what's going on inside, because the SRT is actually using CMake, and configure script will just run CMake under the hood. So let's go hardcore and create a special directory for our build files and going into it. So this is an empty directory. Now I will use CMake to tell that I need to generate build files for this project. I specify that the source is allocated one folder up, so it's here, right, relative to our position. And we can specify something else like build options that we would like to use. But let's try without them, because we want everything to be built by default. Let's see the output generated. Mainly just tells that it's found GCC compiler 9.3 and found pthreads, not found, not found, finally found, and build type will be release, so it will be optimized for release build. Clock monotonic is also something important to notice, because here we see it's available. No extra libs is needed, so it will use monotonic clock, which is good. I will not go deeper into it, but it's one of the options recommended to have SRT. We have monotonic clock enabled here. Yep, so everything is good. Build files are written to this folder that we are in. Let's check. Yep, we have everything here. And now, according to the instruction, we just do make, because we have make file generated, so we run make, and SRT will be built. Let's skip to the successful result. Okay, the build has succeeded, and now we have applications in our folder. So we have srt-live-transmit, srt-file-transmit, srt-tunnel. So these are default sample applications. And we have the library itself, libsrt-so for a shared library, and libsrt.a for static linking of the library. So the main program you would probably use is srt-live-transmit. We can go ahead and run it, srt-live-transmit, and for example, see some help. So it's an application that where you specify two mediums, UDP or SRT. srt-live-transmit just directs or routes packets from input to output. For example, we can specify srt-live-transmit. srt-live-transmit. Let's say I have some UDP input, and I want to read from port 4 5200, for example, but it's actually any port you would like to open. And srt-live-transmit will read the received packets on this port and transmit it to some other destination. It can be UDP, so I can do UDP something IP 5000, for example, right? Or what's more interesting is I want to use SRT. So this command line, this URI will be the same as for UDP. So for example, I want localhost connection here. We can provide an additional option -v, which will enable Gerber's output and will show what's going on there. In this case, port number is wrong. Okay, so now it's trying to connect to localhost port 5000, but there is nothing there because we're not listening to anything. So, for example, just how the successful connection will look like. Let's open another instance of SRT and srt-live-transmit. And I will, for example, receive SRT stream. Will be listening on port 5000 and want to route it to some localhost UDP, say 5001. Okay, so he will be listening. We see that it's bound on ports and listening. He will connect and connection is established. Right now there is nothing sent on this port, so we just have a connection, but nothing is transmitted, but it's already up and running. So let's move on to installing something we can play with. And let's first take a look at FFmpeg. FFmpeg supports SRT. Find a link to the very useful resource SRT Cookbook in the README of the project. So SRT Cookbook, there is some page on FFmpeg. So let's open terminal. Just go to projects and to sudo apt-get install FFmpeg. FFmpeg is installed. Let's see what we have there. FFmpeg. So we can first check out version of FFmpeg and we can verify that we have SRT here by running FFmpeg-protocols. And we see that there is no SRT here. In that case, we need to go back to FFmpeg website, go to download page, see Linux section and static build. So this has the latest static build of FFmpeg, release version 4.4, and let's take this 64-bit version. Save it. Now it's there. We go to downloads and unpack it. Now let's see what we have here. FFmpeg. Here we have the prebuilt FFmpeg. So FFmpeg protocols. And yeah, now we see SRT is available in this build. However, I noticed that for some reason there is no play here. So we would need to keep our default version of FFmpeg to use. I will open a new window here and let's go to Cookbook web page. On the FFmpeg page there are some cases, examples of how can we run FFmpeg. And for example, we can run FFmpeg with SMT bars test video source. And for that we don't need any source video, we just use this example. And it will try to connect to localhost listener. Let's try this. we say that we want to use local FFmpeg for it because the remote one doesn't have, sorry, not the remote, the one installed doesn't have. And we want to connect to remote, so now we have a certain difficulty because the FFplay present on the system doesn't support SRT. So normally if it did support SRT, and it can if it was built with SRT support, I can do, which port do I need here? The port should be 4200. I would do just this way, and it will establish connection, but we don't have this protocol here. In that case, we will do a trick. Here is an example of how can we do this. We use the srt-live-transmit, which will accept SRT streaming and just redirect it to a pipe, to std out, and then FFplay will take this std out and try to use it as a source. For this, we go to projects and SRT. Here we have build and the srt-live-transmit. So now we can run srt-live-transmit. srt-live-transmit, and I need to specify IP and port. IP will be localhost, so we can leave it by default, and port will be 4200. So this URI means SRT listener waiting for incoming connection, and the URI we have in FFmpeg, which is like this, has a remote IP, and port means that this peer will try to establish connection to remote IP on this port, so it will be a SRT caller in this case. So let's establish listener and caller. Here we see that connection is established, and yep, now we see the video going and the sound going here. So that's the least we can do. We can go to FFmpeg filters, and here we can see source filters. I will just Control F, video source filters, and for example, this set filters. We see SMT bars, test source, and so on. So all this can be used instead of a real video to start with, to have a quick start. And also important thing is in protocols, go to FFmpeg protocols. Here you can find SRT protocol and the list of options available for this protocol. So all these options are important. Most of them are for advanced usage. What's the most important option here is the latency. Latency in FFmpeg is defined in microseconds, while in SRT and in srt-live-transmit it is expected in milliseconds. So that's one important difference. The other thing is that this is the receiver buffering latency, which is used by SRT receiver to wait for retransmission. So if a packet is lost for the first time, then SRT will still wait for this latency to try to get retransmission and recover this packet loss. If latency expires, then SRT drops this packet and proceeds further on. So again, to learn more, follow the quick overview video of SRT. The guideline here is to configure latency at least 4 times of round-trip time of your network. So for example, if your network RTT is 100 milliseconds, you can measure it with ping command, for example. If it's 100 milliseconds, then the SRT latency recommended one should be at least 400 milliseconds. This will allow for 1 or at least 2 rounds of packet retransmissions and recover most of the loss. The default SRT latency is 120 milliseconds, and all these socket options can be found in documentation on the SRT GitHub docs API, and actually it's here API socket options. And all the socket options are listed in this table. In particular, latency is also present here. You can see that it's in milliseconds and default is 120 for live configuration. How do you specify these options? Well, it's quite easy as it is available through the command line. Latency is negotiated by both sides. Only the receiver uses it. In our case, the receiver is this FFplay because it receives the packets. And to specify the latency, I can set latency equals, for example, 400 milliseconds. And here we specify latency for srt-live-transmit, and as I told, it uses milliseconds. I can do the same and specify the latency on this side, on the sender side, and then I am adding this query option latency equals, and now I need to specify it in microseconds because it's FFmpeg right now, so it will be 500,000 microseconds or 500 milliseconds. And after a connection, SRT negotiates the latency, and the highest latency will be used. For example, if I would say latency equals 200 milliseconds here, after connection is established, still the negotiated latency will be 400 because this side provides the highest latency value. I could specify 500 here, then the latency of in the connection will be 500. So that's something too important. You can also find some guidelines in Cookbook and GitHub, and that's the very basics to try and check SRT in action. Hope you enjoyed the video and have a good time.